Okay, so yesterday we have seen like you know the disk management, right? How to attach a disk, how to make partitions, how to mount them, and how to unmount also, and permanent mount as well. Another thing is df commands. How to check the disk usage, disk free. I mean, how much available, how much free. So all these things we have seen yesterday. Today we will see about memory management. No, it's like how much memory are there. Similar way for memory. Okay, let's see. Let's see how I mean, what type of memories are there and how it works and everything. Okay, let's see now. So, see, I've seen disk. I mean, how to check a disk, hard disk, and everything. So another important thing is memory, obviously. So CPU, RAM, and hard disk. These three are the main components right in a system, any system. So yesterday we seen disk. Today we will see memory. So how to check the memory? I mean, where to check the memory? I don't. I mean, how to see how much free memory, how much they're using, blah blah blah, and all those things. There are a few ways to do it. One way is free command. Just type free. It'll show something like this. Again, so yesterday we have seen right. This will show you in bytes. We can't understand in bytes, right? I mean, we can understand, but it'll take time. So I want in memories. Sorry, MBs. Free hyphen M I'll use. See, 1 GB, 949 MB total memory. It seems. It means 1 GB. Using is 116 MB, free 630 MB. This I'll explain you now. No, MB also maybe not. I don't understand. I want to see them in GBs. G all are zero because they are less than a GB. That's why. So for us case, let's keep it M. Hyphen M means memory. So let's go to fields. This fields first, and then we'll come to this later. This means obviously total amount of physical RAM on your system. Used means the amount of memory that has been used currently or currently being used by some process or programs, whatever it's running. Free it means how much is free as of now. So these three, it's clear, right? I mean, there is not much effort in that. The next three, you have to remember. So what is shared? Shared means so what happens is there is a file system called tempfs, tmpfs. In our usually it will be in sorry, usually it will be somewhere in our system tempfs. So what it will do is that tmpfs file system, it stores files in the main memory, and let's say you are trying to access it, or let's say a process is being shared by multiple services or multiple what is it, programs. At the time tempfs will store it in main memory so that it will be easy, right, to access. So let's say I'm accessing a file, some test file. So when you open a file, what will happen? It will read. We are reading the disk. I mean, the disk will operate you and gives you the output, right? Generally, disk sometimes will be slow. Generally, I mean, disk will be normally compared to memory. It's slow to load something. So this temp will share the sorry will store the file whatever we're accessing in memory. So now what happens when we access the file? It will be faster for us. It'll open faster. That's the difference. That's what about share. I mean, like let's say so many programs are using a test file, are opening a test file for some reason. So what this will do? This will store the test file in memory so that it will be easy for everyone to access it, and it will be faster compared to disk. So that's where uh, this one shared will come. So next to have buffer and cache, not cache. This is a memory actually. Let's say what buffer will do is buffer and cache both. I mean, it will store the recently used data, so that it can be accessible quickly. So similar way of share, but shared will store the file. Here the data, any kind of data, whatever it is. This will store. I mean, with buffer and cache will store the data, frequently used data recently, so that next time if someone try to access the same thing or try to fetch the same data, it will give from cache. You know, right? Cache. What is cache? I mean, general cache. The same thing. I mean, if you, as an example, like for example, I can give any website. I mean, if you open any website, if you reload something, it will mostly take from cache. I mean, it's already we open it for the first time. Memory will store it a little bit, not whole page. It won't store. It will store some part of it in the memory. And when you try to open again, it will give from there directly. Let me show you where is it. Yeah, let's see here. See, from memory cache. Let me just make it bigger. Yeah. Come on, it's still loading. Okay. See, this is from cache. It's not reloaded again because our memory stores it. And when we try to open it again, it will take it from cache itself so that it won't load at all. I mean, it won't go to internet again. It won't, nothing. There are so many pages like this. See, this one also cache. This is cache. Come on, yeah. See, the same thing from disk cache. See, same thing in Linux also. To store anything, even in Windows also. Will sometimes remove temp files and cache, right? What are those? Same thing, similar thing only. Everything is same. So that's about cache and buffer. It will store the frequently used data in it and gives you fasterly if you try to access it again. Next, available. What is available here is this is an estimated value actually, like how many resources are still open to use. The value is this will change. The value change based on what we open, what we close. So it's like how much is freed up currently and not allocated. So it means it's not used still. So when you open a new process, this will be used, available. You may think what is free then and what is available. You may get free means how much free is there, but what is available? The difference is free means free already being used by other process and it can be shared with some other process also. But available means it's not being used by any this memory, this 695 MB, whatever it is not being used by any process at the moment. If required, it will give. So this might be a little difficult to understand, but try it. Like let's say, think of like an empty room in a house. Let's say a blank empty room, nothing is there, just empty room, no windows, nothing. So here what's happening is it's represent the physical memory that's not being currently used. A blank room is there, it means that's a memory. It's not currently used, right? It's empty. Room is empty, so no one is using it. So in a house, house have three rooms. One room is empty. It means that's ready to be occupied, that is ready to be used, but not used as of now. Another room also there. In another room, there there are one. Yeah, one minute. Yeah. So yeah. So, so yeah. Regarding this free and available memory, the available memory, to keep it simple, it's not being used by anything currently. It's not being used by anything currently. If any new process comes, or if something is required, it will take from available memory. And free is it's already being used and it can be shared. I mean, when there is a some new processor started. So that is the difference. So that's these are the fields I mean about memory. This is the memory line. You might see what is this line. Let's say imagine a scenario that this is 1 GB, sorry 950 MB. Let's say this is full. This is full. All are 000. I mean everything is full. But you want to start something. You want to start a program or some process, whatever it is. We can't, right? If memory is full, you can't even log into the machine. You can't do anything. So what to do now? What to do at the time? We can't increase the memory. See, that is also not possible. I mean, we can increase, but immediately at that time, it's not possible. Got it right? So, what to do in this scenario? If I am like, I can't increase the memory at that time, but I want to run something, but there is no memory. What to do? That's where this swap comes. Swap is a temporary memory. What does it mean, temporary memory? Means it's not really a memory. So it's we create a we take some portion of a disk, or I mean a hard disk, and what we do, we expose it as a memory in something. That's it. Like let's say I have a 10 GB hard disk. I'll take 1 GB out of that. I'll convert that as a memory by using swap. So that will act as a temporary memory. What does it mean is, uh, 1 minute. So yeah, what is this temporary memory? I mean, as I was telling, right? Mm, let's say it's not a real memory. I mean, it won't work just like this memory. It won't be faster as this memory. because we are creating the swap from a disk. Let's say all are full and you want to run something, right? So what this memory will do is it will take some process whichever running in memory and temporarily move to swap, temporarily move to here, so that the space will be free here. I mean the memory will be free, right? So let's say 9 for 116 is currently being used, and if it is full, out of this it will take some and move to swap. And what happens? The memory will be free a little bit, so we can run the process. And let's say once the memory is freed up, swap memory will take back the process whatever it gave to swap. Got it? So it acts as a temporary memory, but not act as a real memory. I mean, it just for temporary case when memory is full, it'll just take swap for some time until the memory is free. Once the memory is free, it will take it back. It won't really run something like that. So, but if it is temporary, why it's required? Because in some cases, I told you right. Most cases, I mean, not in some cases, if the memory is full, we cannot do anything at the time except restarting the machine. But we don't want to restart the machine. It's a production, let's say. At the time, swap memory will be useful. Sorry, swap memory will be useful. But it got stuck. Okay. So, how to, as I told you, right? Swap will be created from a hard drive. It's not a real memory, as I told you. It's not a physical memory. It's from hard disk. We are creating. We're taking some space and we're creating it. So obviously, it will be a little slow compared to normal memory, compared to original memory. I mean. But anyway, it's for temporary, so it's fine. No need of worrying about those. Sorry. So let's for memory you don't do anything. I mean just there. If you add one more memory card, it'll display more memory. That's it. You can't increase here. I mean we can in cloud we can increase, but normally we can't. Let's not increase that because when the class comes, I'll show you. But now we need to see swap. How to create this swap? How to use it. What are some options over there? We'll see those. Okay. So swap can be created in two ways. As I told you, right? Sorry. Swap we create from a disk, any of the disk. And swap can be created in two ways. What are those two ways? One is as a partition we can create. Currently we have only root partition. Okay, we can create another partition. As a partition we can create or as a file. Anything, both works in the same way. First let's create as a partition. Hmm, how to do it? So yesterday we've seen it. How to create a partition. F disk or G disk. Anything. Let's say F disk we can use /dev /xvda wait quit yeah, xvda only, sorry, and yum for help. It shows some options. So what is our requirement? N, add a new partition, right? Remember yesterday? N. So here there is a, yes, enter. Partition number two, obviously, so we have already one is there, xvda one is there with for slash. Okay, two is fine. I don't want to change it. Size, first sector, leave it. How much size? Maybe 1 GB is fine, I guess. Plus 1 GB. It's more than enough. Value out of range. So it's not free.
Already it's mounted on.
Sorry, sorry.
Already
I,
entire volume is in use now.
oh, sorry, sorry. I had to use the wrong disk. Correct, correct,
You are using root volume.
correct, correct. Sorry, sorry. Who's this?
Rasa.
Cool, cool, cool. I forgot. So this already being used. We can't use it. We can try this. Yeah, we have 8 GB. Yeah, maybe 2 GB free is here in this XVDB disk. See, this is correct. See, there is no space. We already used it. I mean, not we. Linux already created a single partition with whole size. So we can create it. That's good. That's good. Now let's XVD. What is it? DB. Because DB also 10 GB is there, but 8 GB are used. So 2 GB is there free. We can use 1 GB out of that, no problem. N for create new partition. Default to 1. Yeah, we don't have 1. We just have 69. Okay, plus 1 plus 1 G. Create a one partition of blah, 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 something. Now we save it. It's created, see, 1 GB partition. It's normal partition, right? Just nothing changed. I mean, yesterday how we did same thing. Then how to make it a swap? That's where the difference is. Yesterday, what I have seen, if you remember, we formatted it, right? MKFS dot yeah, XFS, because we are applying that file system to the partition. It means the file system will apply to that. Now, what is our file system now? Swap, right? So for swap also there is command mkswap slash dev slash xvda, sorry, db1. Am I correct? Yes. Enter. Sorry. Yes, missed. See. So mkfs dot some file system means it will apply the file system to the hard disk. For swap, you have to use mkswap. That's it. Let's see. But still it's not visible. Why is once swap is form, I mean once the file system is applied to this swap partition, we have to turn on it. Swap on slash dev slash xvdb1. Let's see. See, it started, isn't it? See, now it's showing. It's gone. See, got it right. I'll turn on the swap. Why to turn off again? Free hyphen yum. See, swap came 1023. Why it is 1023? We gave 1 GB. If you remember, 1024 MB is equal to 1 GB, not just 1000 GB, 1000 MB. So that's why. See, all are free. I mean, swap is free, not being used. We'll see how it is being used. We'll see that. For now, you got it right. We have to create simple. We have to create a partition, and once we create it, we have to format it with the MK swap. That's when it will realize, okay, this is swap partition. If you do mkfs.xfs, it thinks, okay, it's a XFS file system or ext4 file system. So this creation or partition creation is same. The difference is when you format it, when you apply a file system to it, there it will change. And of course, I did with mkswap. It's setting up swap space version 1 size blah blah c. And this the UID means this ID, so we don't need it. And when once we do mkswap, I mean make swap simple. I mean mk means swap on we have to do. So it will show us swap off. You can disable the swap. And what to do to make it permanent? Open the file, etc slash fs tab. Yes, open it. Go here. slash dev slash xvdb1. Just keep it none. It's swap, right? No mount point, nothing. Just what is the type of swap? SW and 0 0. That's it. Or you can keep it defaults here. We'll see this again. So this is a swap partition, correct? There is no mount point for swap. You don't mount it. Because it's a physical memory. It's virtual memory. Partition type, sorry, file system type swap. Here XFCE to C. And defaults, you can remove this. Save it. Mount icon A. Yes, it's mounted. Then even I restart tomorrow also, it will be there. No problem, right? So I got it. So how this will use and how this will use, we don't need to set anything. By default, it will be used. By default, if the memory is full, it will be used. Only one thing we can set is when it should use. Only that we can set. There is a file actually. So in this file, you can set a percentage. So what happened here is, what is the percentage exactly means? How, I mean, like let's say, how efficiently you need to use SAP. Mm, let me open something, some value. There is something 60 value something so happiness. What is this means? It's a percentage that's the default percentage. I mean, we didn't set it. It's a default percentage. The priority actually. So when to use swap. So the higher the number, the less priority it will get. The lower the number, the more the swap will be used. 60 means average. I mean, let's say, um, I set this as maybe 10 something. Let's say as an example, it's a less value, right? So along with the memory, swap also will be used efficiently. But if I set this 100, swap won't be used unless memory comes to dead. Memory comes to end, I mean. So if you keep higher number, the priority will be less for swap. If you keep lower number, the priority will be high. Let's say now I keep it 100. Example. I'll show you how to do it. So what 100, let's say 100 value. What memory will do is unless this is 950, 949 around, let's say 945 MB is full, then it will start using swap. Then that's, I mean, we don't use it. System will automatically use it. We just set the value, that's it. Let's say 60. 60 means in between, right? 50, 60% out of. So the priority is okay. Average. I mean, maybe after, we can't calculate how much percentage, when it will start using swap, but and guess mode, I mean, we're just doing. So maybe, 60% out of 49. So then it will start using it. So similar to that. So now let's say we can change this value. There is a file called etc. This is the file. Okay, there is nothing. Simple VM dot 10. Let's as an example. Sorry, I don't uncomment it. This is the command to update. Cannot stat. There is a file. Still it says no such file or directory. Proxies, VMs, happiness, yes. It gives. VM not SWAPP. Sorry. Yes. Yeah. I gave the spelling wrong. So now what we did is we set the happiness value to 10. It means the priority little high compared to 60. If we keep it 0, it will be disabled obviously. So the 10 we gave it. So now what happens is on along with the main memory, this physical memory, swap also will be being used by Linux server efficiently because the that's so percentage is. Got it right? So let's say swap memory comes to around 95 MB because or 100 MB as an example because it's 10%. So then it this will swap will start using it. Okay. So when it will start using when we run something inside it. Currently we're not running anything. So let's see. If you run something, it will start. So it will only take care about it. You just need to create and change the swappiness value. That's it. Okay. So got it right about swap. I mean how to create a swap partition, how to make a swap file system, and how to turn on it and make it permanent in FSTAP file. Let's say I have another scenario. I want to increase the swap. I mean, this 1 GB swap is not enough for me. Usually, what generally what everyone will do is, I mean, what in general calculation also, swap should be twice as memory. Let's say if the memory is 1 GB, swap should be 2 GB. If memory is 4, swap should be 8. If memory is 8, swap should be 16. If memory is 16, what is swap? 32. So generally everyone will say swap should be double than memory. In our case, I just created 1 GB. How to increase it? Well, you can create another partition. That's it. It will automatically take it. But let's say in our scenario, our partition's also gone. It means partition's already full. You can create. What to do? At the time, we can create a swap file. What does it mean? Swap file is it similarly works as a partition, swap partition only, but we are just creating a file because we don't have partitions remaining. That's it. So we can now, I mean, in our case, we can create a partition still, but I don't want to create it. This is another scenario, right? So I want to create a file. When we create a file, when we don't have partition, and some people don't want to use partitions at all because sometimes it's risky. So I just want to create a file and use that as a swap. How to use it? Simple. Let's. I think size. How much is there? Yeah, 6.6 GB free. So now I'll create one more GB, 1 GB file. I mean per swap. Use the command allocate -l 1G swap file. This swap file is there. Let me remove this test. See 1 GB file is there, right? Now we have to make it as swap. First we have to give permissions. We only read permissions to this. How to make it as swap? MK swap. Simple. See MK swap, swap on. Well, same thing you have to give. Now check free. See 2 GB. You don't need to do anything. You don't need to link that partition or that file, nothing. It will automatically take care of it. All you have to do is just create a file with allocate, mk swap, and swap all. That's it. It automatically take. See, now it's 2 GB. Now this swap partition and this swap file acts as one. That's it. It's not separate. System doesn't think them as separate things. It's single thing. Got it? It's single thing actually. So is it clear? Any doubts so far?
This 1 GB from where we have to take from
Sorry?
this 1 GB storage from where you have taken from hard disk.
Yeah. Where do you create? That's what the whole thing of swap, right? You create swap from hard disk. How you created 1 GB earlier, a partition? How do you create a partition? From where do you create a partition? From disk only. You can't create partition from memory, right? So swap will be anything. It can be partition or a file. Will be created through hard disk only, from hard disk only, not from memory, anything, nothing else. Okay?
One more thing, we have
Hmm.
allocated RAM as 1 GB, right?
Hmm.
But here in it is showing 949, but
Yes,
we had
okay.
50 MB.
This remaining
We have
almost I think
all
74 MB, I guess. This will be used by system. It will be taken by system. When you from AWS, when you take 1 GB RAM, it won't come 1024 MB. We can't do anything about it. Nothing we can do about it. It's like that.
okay.
This swap we created by ourselves within the server. So that's why it came default fully for us. But it's from AWS guys, so it'll come like that. Let's say example, any there are similar cases you might have seen like this. They'll say monthly recharge, but you'll only get 28 days. That's how it is. I mean, that's not that's a scam, but here it will be using by system wallet, so you cannot see it also. They'll allocate for something.
Okay, okay.
Got it? So any
Yeah,
other
yeah.
doubts
Okay.
on RAM? I mean, RAM, memory both are same. I think you know this. And swap. Any other doubts on this? Hmm?
Will it, will it be possible when I'm doing a partition? Suppose I have a 10 GP, so I'm
Hmm.
like while going to mounting that.
Hmm.
So I'm considering 8 GB. I'm going to use for the file system and 2 GB
Hmm.
for the memory. So while
Hmm.
partition itself, it can be achievable.
Yeah, that's what we did just now. So what we did, let me show. Here, 10 GB is there. I've already used 8 GB, right? See, this was yesterday, not today. And this 2 GB I'm using for swap. Yeah, you can do it. There's no, I told you, right? So if there is a space in the disk and you want to use it for swap, you can use it. That's it. No restrictions over there. Still 1 GB is pending here, but I don't want to use it. I know I want to use it for my data, not for swap. That's why I just kept it like this. That's why I created a file because I don't want to use a partition anymore. That's why I created a swap through file. It depends on you. Like you got a disk. We have systems like in our case, 160 GB memory systems are there. Just imagine 160 into 2. How much it is? 320? 320 GB swap is there in that system. So it depends on our case. How much we want to use, how much we expect for our use case and for our requirement. So you can create like that. Let's say you created a disk 10 GB and you want to use the whole 10 GB for swap. You can use it. Why? Why not? There is no limitation like that. All depends on your use case. That's it. Got it right?
Yes.
Now I can format this disk. I can use it 10 GB for swap. Let me try that. First remove the swap line. I don't want it, right? And I want to turn off the swap because I'm formatting it. Swap off slash dev slash xvdb1 I guess, yeah. Swap off swap file. I think yeah, it's gone. Let me get fs dot xfs slash dev slash xvdb. I think it's correct. This is file system -f to force overwrite. Yes. See, my all my they're all gone. My partitions, everything. Correct? Correct, right?
Yeah.
Now let's see. Shall can I use it for swap? MK swap xvdb. See, swap on /dev /xvdb 3-m. See 10 GB. It came 10 GB, right? I mean, yes, 10,000 MB, obviously 10 GB. So clear? Anything, it depends on our use case. That's it. There is no limitation. Okay, we need to use only 1 GB of swap art, blah blah something. Now we have decided, where we have made it, not decided, the whole hard disk as a swap. See, it's 10 GB now. Correct? Got it right?
Yeah. Yes.
That's how it is. So is it clear?
One more thing.
Say.
Uh, in both cases, whether it may be creating hard disk and partition or file system, in both cases we are getting that storage from hard disk only. No?
Sorry, getting that? In both
Uh,
cases?
we are creating we are creating swap in two ways, right? One is by file system, second one is through creating partition on hard disk.
Mm-hmm.
In both cases, we are getting storage from hard disk only, right?
See, when you create a file, where it will store? In a hard disk only. When you create a partition, where it will store? Hard
Yeah.
disk only. Swap can be created only
Okay.
through hard disk. There is no way else. There is no place else. That's why we call it a temporary
Okay.
memory, not an original one. So when you
Okay.
load memory from hard disk, it will be slow, obviously. Little swap performance will be obviously slow. That's why no one uses for permanently. They use for temporarily. That's why
Okay.
everyone will give a less priority for swap. I showed you swapness value, right? So that's
Yeah.
sorry, that swapness value. Everyone will be maximum keep it 70, 80, or 60 like that. Why? Because they don't want to give priority for that swap. Unless in some cases when swap should be used is when the memory is full. That's it. So not on regular basis. Why? Because it will be slow. Because it's from a disk, right? Obviously it will be slow. That's why. Got it?
Okay. No, got it.
So any other doubts before moving forward?
No, no.
Okay. So we see the free command. There is another command top. We can. I think I showed you, but not these lines. Nobody see. This same thing you can see here. Same thing, right? The CPU will come now, but for now, let's see them. See, in top also you can see if you forgot. I mean, the free command. That's just one command, but if you forgot, you can see it. Now, let's. Memory is done. Disk is done. What is next? CPU. Let's see how to check a CPU. Same thing. Top. See, CPU. By default, we can see the CPU here. So this will show that like how much using, how much idle, all these things. But if you see, in our case, 93%, 93.8, sorry, 93.8% is idle because we are not running anything, just blank. Apart from this, there is one more way. LSCPU. It will show you how many CPUs are there in your server. Let's go to top. Blah blah blah. See, just one CPU is there. I think yeah, just only one. Mostly when you buy a laptop, how many you'll get? I think four or something. Let me see. How to check in Windows? I don't know. Okay, we can see later. So this is one of the command to check. I mean, how many CPUs are there? There are multiple commands to check the CPUs. Starting, we'll see first thing. What is it? mpstat. Let's try what will happen. This will what it will display. Let's say we have multiple CPUs. Let's say it will show you the same thing. Just what we have seen in the top, it will show you same thing, but it will show you for all the CPU cores one by one. But in our case, we just have like only one value, one CPU, right? So that's why it's showing one line. Let's say if you have two, it will show like two lines. So it will show like each processor, I mean, processor means cores. Now, what is the usage they're being used? There is one more value I'll tell later, but we'll see this first. So MP stat is it will show individual level. There is something called SAR. SAR. Every 10 minutes it will show you what is the CPU usage. How do I find that whether it is 10 or not? See the time here. This is UTC time, obviously. So see the time. Every 10 minutes it will show. We can change the value. Like let's say SAR hyphen for every 2 seconds, 5 lines will be displayed. See like this. SAR will be very, very useful, when you're trying to analyze the CPU. Why? Because let's say yesterday night server was down. I don't know why. We are guessing CPU might be the cause. But how to check this SAR? This SAR will work. This will show you the percentage at that time. Now mpstat is one command, SAR is one command. SAR will show you more clear of way. mpstat will show you like what it will do is if your multiple cores, I mean, multiple processors are there, it will show you individually one by one how much each processor is being used. There is one more command. So many are there. IO stat. See this also. These are device disks, but this one, see. Same thing, same values it will be. I mean, by the time we execute this command, the values have changed a little bit, but same thing, everything it will be showing you same. Nothing will change. Let's see another command. See, memory. It will show memory also, CPU also, everything. PM stat. This is one command. Got it, right? So I told you right last time there is one more concept I'll tell you. Finally, we can see in top also, obviously. We'll see these two lines. We haven't seen these two. Let's see these two. These are important. Most common question is interviews is this one when you put Linux. What is this something? Let's see. The first is, let's come from here. This is uptime. This is UTC timing. This is uptime. It means since how much time the server is running. I think 50 minutes it seems. 51 minutes, sorry. And how many total users are there? Three users. I think EC2 iPhone user. There are so many users, right? Why do it's only three means? The users which we created, not root. Root is a server user. It doesn't matter for this. So the users we created is three. I think test user one, Ishwar one name. I think test as well. I think yeah, these three. Next, what is this load average? And what is this common question is? What is this load average? Load average, what happens is, to keep it simple, this is the information about system load over a certain period of time. So it will be 1 minute, 5 minutes, 15 minutes, something like this. I'll tell you. So it will represent the system average load with this specific timings. Like within 1 minute, what is the load? Within 5 minutes, what is the load? Within 15 minutes, what is the load? That's why we see three columns. How it will calculate is based on the number of process that are running over a period of time. So as I told you, right, three fields are there. 1 minute, last 5 minutes, last 15 minutes. So based on the based on the process, number of process we are running, within these three different time periods, it will be the average will be displayed here. So as of now, 00 means we are not nothing. We are running nothing right here. Nothing. We are running. We're just using some free commands. It does not take much. So when you run a real application or something, then it will show you. So do we need to worry about this load average? Yes, when it is high. But how do you know when it is high? I mean, what is the criteria means? Well, high load average depends on number of CPU cores, number of CPUs, I mean, in your system. So currently one CPU is there, right? Correct? As we see in SPLS, sorry, just now. If the value is one in any of these fields, it means the load is high because you have one CPU and one CPU is being used. It means it's high. Let's say if it is we have eight CPUs. Generally, we will see eight or four, and you are seeing one here. It means it's okay. So CPUs are eight, and load average is one. Okay, it's not a problem. But if generally how we consider high load is based on the number of cores, CPU cores. If the cores is one and the load average is one or above, it's danger. Your system will about to go down. So you have to do something. What do you have to do? Check some process, stop something, or restart some process to clear up some memory, CPUs. So these kind of things we do. But before doing it, we'll discuss. We'll ask someone, whether is it okay to do it or not. Correct, right? I could simply can't restart it. I mean, it won't work like that. Got it? So that's about load average. So it will show you average load based on for 1 minute intervals, 5 minute interval, and 15-minute interval. And how this load average will calculate based on number of process that are currently running within this time periods. When this is high, when these values matching or above with our CPU, number of CPU cores, I mean, sorry, that's the difference. So mostly asked question in Linux is load average. Why? Because mostly people will confuse about what is this load average. That's why. So this is one line. Obviously, I've seen CPU, memory, swap. You have seen what is this line? Tasks. Tasks are like number of tasks currently running. So as we can see, how many are running? 108 total, one running, 107 sleeping. Running means it's currently running. Sleeping means it's in sleep mode. It will be run. It will start very soon. Stopped means we stopped it manually, either or it stopped automatically. I mean, the task is done. And we see zombie process. This also sometimes we get asked. What is a zombie process? Is the process it's completed, it's finished, but still the entry exists. So what happens is like typically zombie process will create when a child process terminates. But like let's say for process there will be child process, sorry, there will be parent process and there will be child processes. Zombie will create is all the child process are deleted, but still parent exists. Parents can't able to delete. Then it will move to zombie. Very rarely, I mean not really regularly. We don't see any number in zombie. And in major cases, if you're time bad, so you'll see something. What do we do at the time? We filter out the process with ps command or netstat commands. I think you already know them. We kill the process. manually. That's it. So that's for today's class.
But how we can come to know if it is the zombie process? Suppose if I execute the command ps-a.
So it will show you the, let's say usually, let's find what is there. Apache is there? Not there. 1 minute. Yes, it's running. Have you seen any difference here? It's normal, right? It's looking normal, correct? TCP, blah blah, 80 port number, blah blah. Listen, it means currently listening. PID and the process name. This is normal. This is normal general way. But if it is zombie, you won't see listen. You will see zombie. That's the difference. You'll by looking at it, you'll understand. Okay, this is the zombie process because the way it represents this little change. We can't create a zombie process now. This one I can't show you. But generally, so you'll figure out by that one. So
Okay.
is it clear? So yeah. So that's it for today's class. Anything? Anything? Any doubts? I mean, so far, memory management. Hello.
No, no.
Okay. Yeah. So yeah, that's fine. There won't be a class tomorrow. So we'll start on Thursday. Sorry, Thursday. Okay. I think there are one, two, three, maybe three topics pendings. Maybe it will take by next Wednesday. I think we can finish Linux. I mean, not fully. If you want to learn Linux, it will take 5 to 6 months easily. But whichever is required, whichever is mandatory for DevOps, for cloud, those I'm trying to finish. Got it right? So full Linux topics, it'll take too much time. We'll forget our main thing, which is DevOps and AWS. So whichever required, minimal at least. Not we have crossed more than minimum, but whichever is required to go forward with these topics, DevOps and Linux, sorry, DevOps and AWS. So we're discussing those. As of now, it's done. As of today, the whatever the topics in Linux is done. The next topics, we have three topics. Those will be useful for DevOps only. Those when out of those three, one belongs to Linux, other not, others not, but those will be very useful for DevOps. So that's why. Okay. So Thursday, same time, we'll connect. Got it right? Yeah. Bye, bye
Yeah.
everyone.